I am Jebakumar, Assistant Professor, Department of Physics, Bishop Heber College. In this video, I am going to teach you about the principle behind production of low temperature. The principle has its origin from an experiment called as Joule-Thomson experiment. This experiment involves a gas at a very high pressure when allowed to expand through a narrow orifice whose initial temperature is known. When it expands adiabatically, the following observations are seen. The first observation is, at ordinary temperature, all the gases except hydrogen and helium show a cooling effect when it expands adiabatically. The second observation is, when the initial temperature of all the gases is sufficiently low, then all the gases including hydrogen and helium show a cooling effect. The third observation is, the fall of temperature of the gas after adiabatic expansion is found to be directly proportional to the difference in pressure on the two sides of the porous plug. That is, if the initial pressure is very high, then after expansion the gas suffers a large fall of temperature. And the fourth observation is an important observation, which is the fall in temperature for a given difference of pressure. That means, for a given difference of pressure, different gases were taken and allowed to expand, and it is found that the decrease in temperature after adiabatic expansion is indirectly proportional to the initial temperature, which means when the initial temperature rises, the fall in temperature decreases. The fifth observation is, for every gas, if you go on increasing the initial temperature, there is a particular temperature at which, even after adiabatic expansion, there will not be any change in temperature, which means that there is no cooling effect. The temperature at which this happens for a gas is called as the temperature of inversion for that particular gas. And the sixth observation is, for any temperature, that is the initial temperature of the gas, which is greater than the temperature of inversion of the gas, when that gas is allowed to expand, there is a heating effect instead of cooling effect. So, based on this observation, you can define a effect called as Joule-Thomson effect. When a gas at a initial high pressure allowed to suffer throttle expansion through a porous plug into a region of constant low pressure adiabatically, you have to underline the word adiabatically. If the expansion is done adiabatically, then in general there is a change in temperature of the gas. You have to note 3 points. The initial pressure is high and it expands into a region where the pressure is low, and this expansion takes place in an adiabatic environment, and the result is there will be a definitely change in its temperature. So we are going to exploit this effect and combine it with other effects to produce low temperature.